Okay, good morning or good afternoon, Year 12. We are on Chapter 3, Lesson 4. There is a competition inside this video. Up to you to work out what the competition is, what the topic is, and how many there are. Right, we're going to look at the proof of the sum of a GP today. And to do that, before we look at what the proof is, we are going to just remind ourselves of what a geometric progression is. So title in your books, what a geometric progression is. So, a geometric progression is something like this. 1 times 2 times 2 times 2 times 2. It has a common ratio r. Okay? So if I call the first term a, and the second term is a times r, for example, 1 times 2. Then I'm going to times by r again. And I'm going to times by r again. And I'm going to keep on going until I get to my nth term. Remember, this here is your nth term. Now, what does the sum mean? So the sum to n terms means I'm just going to add up all of these terms all the way to the nth term. Now, to look at the proof of what the sum to n terms is, I'm going to do a little trick. I'm going to multiply each term by r. So a times r, this one times r, next one times r, plus I'm going to times the last term by r to get this. Right, just to make sure you understand what I'm doing here, a little bit of sub-working, okay? So, this term here, the nth term times by r. Let's just do that at the bottom here. The nth term times by r. This is r to the 1. What do I do to the powers? When I'm multiplying, I add them. So I will have n minus 1 add 1, which is ar to the n. So that's just how did I get this times r gives me here. Okay, now what I'm going to do to the top equation and the bottom equation is now to subtract them. Okay, so I'm going to start off with the top equation and I'm going to subtract the bottom equation. What happens? Can you see what happens here? Well, a take away nothing will just give me a. These will cancel. Remember, I'm subtracting. Everything is all going to subtract. This will subtract with the one before. And I've got, whatever this is, subtract the last term here. So, now I can create an equation for the sum to n terms. If I factorise on the left-hand side, and I can factorise on the right-hand side. And then just rearrange and you've got your sum to n terms. Okay, so I would like you to write that method, please, into your books. And you need to learn that method. This proof will come up in the exam. You may be asked to prove the sum to n terms. This formula is given to you in the exam, so you don't need to learn it, but you do need to know the proof. Right, so how are we going to use this formula? Let's look at an example. Okay, so one I made earlier, here. I want you to find the sum to n terms of this sequence here. So, I'm just going to write down the formula again. Here's the formula for the sum to n terms, which is given to you in your formula booklet. So, I have got my first term is 1. What's my common ratio? Well, 3 divided by 1 is 3. Yeah, it's going up. I'm timesing from each term to the next. I'm multiplying by 3. And I've got 20 terms. So, n is 20. So all I have to do now is sub each of these into my formula and work it out on a calculator. Okay, so just work that out on your calculator. 1 minus 3 to the power of 20 equals divided by -2 equals. So I get a huge number. I get this. I'm not going to even attempt to say it. That's my answer. Okay, so just check you can do your calculator and you get the same answer. Okay, right, another question, slightly harder now. What about if you had this here? Okay, this sequence here. Right, is it a geometric progression or an arithmetic progression? Well, yeah, I can see from term to term, I am timesing by a half from each term to the next. I'm not told how many terms I've got, but I'm told what my last term is. So I know R is a half, I know A, but I do not know N. So the first thing I'm going to do is I'm going to find N. What should I do to find N? Well, I know that my last term, or my nth term, this is the rule for my nth term, is this. So using this rule, my nth term, in this case, I'm going to look at my last term, is A times R to the n minus 1. So if I can solve and find out what n is, I will know how many terms I've got. Okay, so I'm going to do this first. Now, what do I do if the unknown is in the power? Yeah, you've got it. You're going to use logarithms to solve it. So I'm going to log to the base 10 of both sides. So I just write this. To be honest, it doesn't matter what base you're using as long as it's the same. We normally use log to the base 10. In some circumstances, we use ln. Okay, so we've got that. Now I can release the power. Yeah, I'm going to release our inner power now, guys. So I'm going to bring this power in front. So I've got this. And now we can nearly have got the answer. So I'm going to divide now by log of a half, both sides, and I can find n. So let's just do that on your calculators. So I'm going to do log to the, I have to put base 10 in this calculator, 1 over 1024 equals, I get a negative answer for that one, divided by log to the base 10 of 0.5. So if I do that, this divided by this, I'll get 10 on my calculator. Okay, and then I'm going to find n. This will equal 10, so n will equal 11. Okay, so I've got 11 terms here. Now I'm going to put all of that into to find the nth, to find the sum to n terms. So the sum to n terms, let me just write down the formula again. Always do this at the start of each question. So I've got my A, I've got my R, and now I've got my N. So you're going to put it all into this equation and work out your answer. Sorry, that was a mistake. That's a negative sign there. Okay, so put all of this into here, and if you work that out, just check you can get this on your calculator. Just do it a few times until you get that answer. If you think I've made a mistake anywhere on the video, I might make some deliberate mistakes. First one to spot it and send it in to me will also get a prize. All these prizes I'm going to give out next week when I see you at school. Okay, so another question, guys. Right, this one. Example 2. Find the least value of n so that the sum of all of these exceeds 1 million. Okay, so let's look at how we would do that. The least value of n. Right, well, let's just write down the sum to n terms again, making sure it's a negative sign there. Right, so what do we know? Well, we know a is 1, we know the common ratio is 3, and n we want to find out. But if I'm going to make the sum to be 1 million. So I'm going to put this into my rule. And we're going to work out what n is. So I'm going to times both sides by -2, so I'll have -2 million. We'll equal this. And I'm going to bring the n this side, and I'm going to add 1 to 2 million. Okay. So what do I do when n is in the power? I take logs on both sides and I'm going to release the power. I'm going to bring the power down. And I will have this. Therefore n will equal log of 2,000,001 divided by log 3. So if you put that on your calculator, let's see what we get. Okay, so if you put that onto your calculator, you will get 13.2 for n. So if n is 13, your sum will not quite reach 1 million. So my answer is the smallest value of n to the sum to exceed 1 million will be 14. 13 is going to be slightly too small. Obviously n has to be a whole number because it's the number of terms. Okay, next example. Right, I want you to turn to page 73, question 9 in the book, and I will look at this question here. Have a go yourself if you think you understand this all. This is a difficult question, okay? And then you can just forward, if you got it right, you can just fast forward the video. Okay, so I've got a geometric sequence. I'm told what A is. Well, I'm just told A is A. I'm told the common ratio. And I want to show, so the question is to show this. Right, so what's my value of n? Well, this is the sum to 10 terms, so I need to show that n is 10. So all I'm going to do is plug everything into my formula. So this is my formula for the sum to n terms. Always write this down. The more times you write it, the more you will remember it. So n is 10, a is a, 1 minus root 3 to the power of 10 over 1 minus root 3. Okay, and I'm looking to get back to here. Okay, and I've got this so far. So what can I do to simplify what I've got here? Well, I think I'm going to work out what root 3... So I'm going to work out what root 3 to the power of 10 is. Let's just see what that is on my calculator. So if I put that on my calculator, I get 243. Okay, so I'm now going to put this into here and see what I get. I'm just going to simplify the top and I will get this. Now, I can see that the answer I'm trying to get to is here. Okay, so I've got no roots on the bottom. So what's the only thing I can do now to get rid of what's on the bottom is to rationalise the denominator. So I'm going to times top and bottom by 1 plus root 3. And by rationalising the denominator, remember this is minus, this is plus, I will get rid of the square roots on the bottom. Okay, so I will now have, this will be this. So I can see I've got my 1 plus root 3, which is in the answer I want. And this will be just 1 minus 3 if I multiply that out, i.e. minus 2. So I've got minus 2 on the bottom, therefore I divide 242 by minus 2, I will get 121a times 1 plus root 3, which is what I want. The key here is knowing to rationalise the denominator. And you all know that this would be just 1 squared minus root 3 squared, i.e. 1 minus 3, because the roots will cancel each other out. If you're not sure about that, just multiply that out for yourself and see what happens. Okay, so that was question 9. Right, let's look at one last, I've got 1 or 2 last questions. I've got 2 last questions to do, 2 difficult questions. We're going to go to question 10 now. Okay, so you're going to have a look at question 10 on page 73. You do it yourself first and see how you do, and then look at my answer. Okay, we've got first term A, common ratio 2. That's for the first geometric sequence. Okay, a different geometric sequence has first term B and a common ratio of 3. Okay, so this is another term, another geometric progression. Given that the sum of the first 4 terms of both series is the same, okay, so the sum of the first 4 terms, okay, I just call that the different sequence. The sum of the first 4 terms are the same. Show this. That's what we're trying to show. Okay, so get your thinking heads around this. The first thing I'm going to do is I'm going to find the sum of the sum to 4 terms for both of them. I'm going to put them both into my formula. So I know this is my formula. I'm just going to write it out again. Okay, so if I look at the first geometric sequence, okay, so I'm looking at the sum to 4 terms. I've got my first term is A, 1 minus 2 to the power of 4 over 1 minus 2. And if I look at the second geometric sequence, the sum to 4 terms for this one, my first term is B, my common ratio is 3, and I'm doing it to 4 terms. Now, we know that these two are exactly the same, so we are going to put them equal to each other. And then we are going to rearrange to find this equation here. Okay, let me just see if I can simplify this a little bit. Well, I know that this one here will be A times negative 15 over negative 1, which is going to be 15A. And this one is going to be B times, or what's 3 to the power of 4? 3 to the power of 4 equals 81, take away 1, is 80 divided by 2 is 40. So this is 40B. So I'm going to now put these two equal to each other. So I know 15A equals 40B. I want to find A. So I get this. Divide top and bottom by 5, and I get what I want. Okay, another lovely question. Well done if you got that right. Okay, and one last question. Have a go, guys, at question 11. Okay, the last question. Have a go and tell me, well, you have a go and see how you do, and then you can check with me how well you're doing. Okay, so question 11. You've got the first 3 terms here. of a geometric sequence. So we have a common ratio r. K is a positive constant, and we first of all want to show the quadratic equation. Right, so what do we know about this? Where are we going to start, guys? Well, I know that the common ratio is going to be the same all the way through. So, to get from one term to the next, I'm timesing by r. So, r will be the second term divided by the first term, which will be the same as the third term divided by the second term. Just in case you didn't quite get that, let's just look at an example. I know in the lesson some of you might be a bit concerned about that. Let's say I had this geometric sequence, yeah? Well, I can see r, the second term divided by the first term, is the same as the third term divided by the second term. Yeah? That's all I've done. Right. So I've got this equation now, and all I'm going to do now is rearrange it to get the quadratic that I'm asked to get. So I'm going to, let's just put a piece of paper over that. I'm going to times both sides. I'm going to bring k here and get k squared. I'm going to bring the k minus 6 up. I'm going to multiply out 2k squared plus 5k minus 12k minus 30. Okay, I'm going to take all my k squared to make it positive. So I will have this, and hopefully, yeah, just checking the answer, that's what I want to get. Fantastic. Right, now part B. Part B asks us to find what k is. Okay, so I'm sure we can do that, and I'm sure it will factorise. Yeah, it does factorise, so just factorise this quadratic. Okay, so I'm going to factorise it. 3 and 10, yeah, that's a good one, 3 and 10. And I want the 10 to be negative. Okay, so k is negative 3, or k is 10. However, you're told k is positive at the beginning, so that's my answer. Okay, next, find the common ratio, r. Well, let's look at now my sequence. Okay, this was my sequence at the beginning. This is what I was told is the first 3 terms. So, if k is 10, 10 minus 6, 20, 25. So, my common ratio will be 10 divided by 4 or 2.5. That should also be the same as 25 divided by 10, which it is, 2.5. So, r is 2.5. And the last bit, B, find the sum of the first 10 terms of the series, giving your answer to the nearest whole number. Pretty easy, guys. Just plug everything into the formula and you will get this. I'm not going to do that one. You should be able to do that now. Right, okay, end of video. I enjoyed that. Hope you did too. Right, your turn. This is what I'd like you to do. Obviously, you can do extra questions. Lots of you are doing that because you want to get predictions of A stars. So do as much as you can, send it to your teacher, and have a lovely day.